This is going to be our fourth and final example of Objective 66. This one's going to be quite involved. 2x over x squared plus 5x plus 6 minus x plus 1 over x squared plus 2x minus 3. Alright, first thing I need to do, I need to get common denominators here so I can actually subtract these fractions. But in order to determine that, I need to write things out in their factored form. X squared plus 5x plus 6 will factor to x plus 3 times x plus 2. And x squared plus 2x minus 3 will factor to x plus 3 times x minus 1. Now, as I examine my two fractions, I notice that the common piece in those two denominators is the x plus 3, and that I have an uncommon piece from each other fraction. So in order to make them the same, I'm going to multiply my first fraction by the uncommon piece of the second one, so that x minus 1. And I'm going to multiply the second fraction by the uncommon piece from the first fraction, so multiply that by x plus 2. I'm left to now distribute the 2x to the x minus 1. So I'm going to have 2x squared minus 2x all over the quantity x plus 3 times x plus 2 times x minus 1. That's going to be subtracting. Here I need to FOIL. I'll have multiple distribution here. So it's x squared plus 2x plus x plus 2, which when simplified becomes x squared plus 3x plus 2 all over x plus 3, x plus 2, x minus 1. Now I have common denominators, so I can go ahead and combine these things through subtraction. Now as I go from one fraction to the other, remember to travel through this minus sign. This is like a distribution kind of thing with the negativity. Okay, so watch out for positives and negatives here. We're going to have 2x squared minus x squared, which is x squared. I'm going to have negative 2x minus 3x, which is negative 5x. Now I don't have a constant term here, so it becomes negative positive 2, which makes it negative 2. All over x plus 3 times x plus 2 times x minus 1. Now in terms of subtracting, I'm done. I just need to double check and see if that trinomial x squared minus 5x minus 2 is factorable, because if it is, I need to factor it to make sure that I don't have pieces that will cancel with the denominator. So I will try to do our trinomial factoring method on this. 1 times negative 2 is negative 2. The only factors I have of negative 2 are negative 2 and 1, or 1 and negative 2, which do not equal 5. So this trinomial becomes prime, which means that that is our final solution.